Hello, all you big, beautiful brains out there. Today, we're going to talk about your senses. Before we get started, take a minute to subscribe to Psy vs. Psy. Help out your friendly neighborhood psychologist while I tell you all about your senses. When psychologists talk about your senses, we mean all the different ways that your brain can get information from your body about the outside world. All of your senses send that information back to your brain. It's your brain that processes that information, and that means that it's critical for psychologists to study senses because a lot of our brain power goes into interpreting that information. In this video, I'm going to focus on giving you a simple explanation of how that information goes from your sensory organs into your brain. Let's start with a sense you know, like the back of your hand, touch. In your skin, you have receptors that detect lots of different things like pressure and stretch. A lot of the receptors are grouped by the layer of skin. For instance, the discs that sense light pressure are found very close to the surface of your skin. Your sense of touch is one of the first senses that you develop at about 8 weeks in utero. And touch is one of the fastest ways to release endorphins, which make you feel good. When you were little, did you ever have your mom kiss your boo-boos? Yeah. Touch makes us feel better by activating those opioid receptors. In fact, kangaroo care or touch therapy with skin-to-skin contact is critical for the physical and brain development of premature babies. Now, let's take a look at your eyes. Vision works because we have special photoreceptors that convert the light we see into electrical information that our brains can understand. Your brain has to work with your eyes in order for you to see. And your eyes are a complicated mechanism. They have over 2 million working parts, and your eyes are very unique to you. You know those fingerprint scanners like on the back of your phone that you use to unlock it? Those work because your fingerprint is so unique. The scanner can find about 40 points that are unique to you. If you use a retinal scanner and scan your eyes, there's more like 250 points that are unique to you. Some scientists even consider retinas to be a part of the brain because they are so dense with neurons and the first stages of visual processing happens there. Next, let's talk about your hearing. Your ears work by sensing vibration through membranes into a fluid-filled sac that looks kind of like a swirly snail shell. It's called a cochlea. When pressure forces the fluid inside the cochlea to move, it shifts tiny hair cells. Those hair cells then send neural impulses to your brain. Yeah, you hear? Through hair. Your sense of smell is actually pretty easy to explain biologically, but it's also one of the least well studied when it comes to psychology. So, right at the top of your nasal passage, there's a special group of neurons that come in direct contact with air. Those neurons have little hairs called cilia, and when a smell binds to the cilia hairs, it sets off the neuron so that your brain perceives a smell. What makes smell so hard to study psychologically is that you have an estimated 400 different receptors for smell, and a lot of how you perceive smell is based on your prior knowledge of other smells. It gets complicated to separate really quickly, and it's definitely an area where we need technology to advance to help us figure it out. I'm looking at you, future scientists. Believe it or not, there's another sense that operates using hairs: taste. On the surface of your tongue, you have receptors called papillae with tiny hair-like bumps. Those tiny hairs react to dissolved food molecules. Don't worry, you dissolve the food molecule yourself. That's what spit is for. Another interesting thing to note, if you've ever seen this map before, it's totally wrong. Your taste receptors for salty, sour, sweet, bitter, and umami aren't separated into zones. They're pretty evenly distributed all over your tongue. Also, you don't actually have a taste receptor for spicy. That's a separate thing called a nociceptor. But what's a nociceptor, you ask? Nociception is actually a different kind of sense. So far, I've only talked about the senses that you do know, but there's actually quite a few senses that you might not even be aware of having. Let's take a look at a few of the weirder senses. So, nociceptors are sensory neurons that respond to pain. There are a few different types, but they mostly operate the same way. When something happens to your body that's harmful, that activates the nociceptors in that part of your body. They send an electrical signal that your brain interprets as pain. One type of nociceptor, called a chemical nociceptor, specializes in responding to chemical stimulants like spices and capsaicin. That's why foods heavy in capsaicin, like peppers, taste spicy. Our brain interprets the activation of those nociceptors as pain. Hurts so good. Other weird, wild senses include things like your vestibular sense. The two senses I'm going to talk about after this one kind of depend on the vestibular sense for some of the information. Your vestibular sense is your sense of balance, and it's actually controlled by a tiny sensory organs that are found in your ear right next to your cochlea, which we talked about earlier. They respond to the movement of your head and gravity. And when those tiny organs, hair cells, are stimulated, they send information about your spatial orientation. So like if your head is lower than your feet. If you get sick on boats or on roller coasters, that's probably the sense to blame. Another weird sense is your kinesthetic sense. And I'll tell you about this one, but it might be easier to show you first. Okay, so right now, if you're in a safe spot, close your eyes. Please don't close your eyes if you're driving. The channel doesn't want to get sued. Okay? Eyes closed. Now, without opening your eyes, point to the closest door. All right, open your eyes. How close were you? That's a simple test of your kinesthetic abilities. Your kinesthetic sense is your sense of where you are moving in space. Your kinesthetic neurons are found all throughout your muscles and your tendons and your joints, and they rely on the interaction between those receptors and your central nervous system to tell your location and how you're moving through the world. Another really related sense is proprioception. Your proprioceptive sense operates in basically the same anatomical way as your kinesthetic sense, but it's less concerned with where your body is in relation to other things, like the door, and more about where your body is in relation to itself. For instance, if I told you to close your eyes again and put your arm straight out, you would know that your arm was out there. You don't have to look at it to tell or to feel it with your other hand to make sure that your arm is still there. Proprioception makes sure that you know where all the parts of your body are at all times. What makes your kinesthetic sense and your proprioceptive sense really neat is that they've been found scientifically in other living things besides just animals. Flowering plants also have these senses. So, if you've ever enjoyed the beauty of a sunflower tracking the warmth of the sun during the day, now you know which sense to thank. The last one we're going to talk about is your thermoceptive sense. This one has a name that's easier to remember, thermo like thermometer, because this one's all about your sense of hot and cold. And this sense is fascinating to me because it's probably the one we know the least about. So what we do know is that you have thermoreceptors all throughout your skin and in your body's tissues. And when those thermoceptors are activated, they send an electrical signal all the way to your brain, which your brain interprets as all the temperature information that you get. So hot or cold or a sudden temperature shift, all of it. This is a sense that is going to need to be studied a lot more before we understand it completely. Even just basic things like, is there one temperature system or do we maybe have two? One for the temperature inside of our body and one for the temperature outside of our body. Is that why we feel weird and kind of disconcerted when we have a fever? Even though feeling hot or feeling cold seems like a pretty basic thing that we all do all the time, we still don't really fully understand it yet. And that's one of the reasons why exploring these sensation processes is so important. As psychologists, we're never going to fully understand the brain until we understand how our brain interprets and processes all this wonderful sensory information that we get every single day. So, if you want to find out more about your big, beautiful brain, make sure you subscribe to this channel so you can get all of our other videos, and you can learn all about the science of psychology. Until next time, keep thinking, and I'll see y'all later. Bye. I'd like to dedicate this video to everyone who just found out that there's tiny hairs on your tongue.